Hi everyone, I'm Sugi Park. Today I'll present our work on free-grained hierarchical visual recognition. Most conventional computer vision methods assume a fixed label granularity. They expect every training image to be labeled either at the single flat level or along a complete hierarchical path. But in reality, annotations are rarely perfect. Depending on visual ambiguity, distance, or annotator expertise, a distant bird might only be labeled as a coarse-level bird. In contrast, a clear close-up shot of the same bird justifies a very specific fine-grained label like bald eagle. To bridge this gap, we define a new task called free-grained recognition. This task requires models to achieve three goals. First, learn from mixed granularity labels across instances. Second, maintain global taxonomic consistency. And finally, perform adaptive inference to choose the deepest reliable level supported by visual evidence. To systematically evaluate this setting, we need a comprehensive hierarchical dataset. Existing datasets are often small-scale or limited to very specific domains like birds, aircraft, or biological categories like iNaturalist. While useful, they don't fully test whether a method can handle free-grained labels in a broad, general visual recognition setting. Therefore, we built a larger and more general benchmark based on ImageNet with a clean three-level hierarchy. If we look at ImageNet's original WordNet hierarchy, the taxonomy is highly inconsistent. For example, as shown here, a minivan has 4 different hierarchical paths with different depths, making it ambiguous which path to predict. On the other hand, a teddy bear has a very shallow depth, so its fine label corresponds to the level of container for a minivan. This creates a severe mismatch in specificity across levels. Because our task requires predicting the entire hierarchy correctly, not just the fine-grained labels, we created ImageNet3L, a clean, balanced three-level taxonomy inspired by cognitive psychology. After building this hierarchy, we create free-grained labels by pruning fine-level labels in 2 ways. The first is foundation-based pruning, where we use visual ambiguity estimated from foundation models. The second is randomized pruning, which serves as a controlled setting. The examples here show foundation-based pruning on ImageNet3L. It captures ambiguity quite well. Distant bird here are labeled only as bird, while close-up and visually clear examples keep their fine-grained labels. Crucially, when current state-of-the-art hierarchical methods are tested under this realistic free-grained setup, their full path accuracy deteriorates sharply, dropping by up to 40%. To compensate for this missing supervision, our first solution is text attribute. Even when fine labels are missing, visual traits like short legs or upright ears are shared across levels. We use a vision language model to generate detailed descriptions and align image features with text. This allows the model to capture shared pseudo-attributes that generalize across the hierarchy. Our second solution, Taxon SSL, treats missing labels as a semi-supervised problem. It generates multi-level pseudo-labels and pulls samples together only if they share consistent labels across the entire hierarchy. As shown in the table, our approaches consistently outperform prior hierarchical SOTA across multiple datasets, achieving up to an 18 percentage point absolute gain. Interestingly, our analysis reveals a clear trade-off. Text attribute excels when fine-grained labels are extremely sparse by leveraging external text knowledge, while Taxon SSL thrives as more data becomes available. Finally, during inference, instead of relying on standard confidence thresholds, we stop predictions when taxonomic constraints are violated. This consistency-based rule reaches deeper, more reliable crack levels. In conclusion, we introduced a highly practical visual recognition task, curate clean large-scale benchmarks, propose 2 complementary solutions, and validate a robust adaptive inference strategy. Thank you for your time. Our code and data are publicly available at our GitHub repository.